In this section, we are starting chapter 10, and we are going to be introducing ourselves to things about degrees and radians and angles and all kinds of different things. So this first couple of pages that we're going to do is just kind of a little bit of background on how to do things with degrees and radians that we did last year in Algebra 2, and then we'll get into some newer stuff with angle of inclination. So just a quick reminder here of some things. Radians are just another way to measure an angle. Right? In Algebra 2, we introduced radians just a little bit, but generally speaking, we always used angle, like degrees, in order to measure angles. So you can also use radians. Basically, as you get into higher level math and into things like engineering and that kind of thing, a lot of times they will use radians instead of degrees in order to measure angles. So, and just a reminder also from last year that pi is 180 degrees and 2 pi is 360 degrees. So pi is like a straight line, right? That's 180 degrees. 2 pi is like the circle all the way around 360 degrees. We use what's called the unit circle to help us with converting from radians to degrees and vice versa, but we'll look at that later in the unit. For right now, we're just going to use our calculator and stuff to go between degrees and radians. Okay, so to go from degrees to radians, okay, we did this last year in Algebra 2. You take your however many degrees you have, and you multiply it by pi over 180. So just remembering a little bit here that pi is 180 degrees up here, right? So if we have pi over 180, it's essentially like multiplying by 1, because pi is 180 degrees, and 180 degrees is 180 degrees. So when we do it, we're not really changing the value of the number, we're just converting it from one thing to another. So if we were going to convert 60 degrees from degrees to radian, we would take 60 degrees, and we would multiply it by pi over 180. And for these right now, we are not going to use 3.14 or anything like that for pi. We are just going to leave it as a simplified fraction. So we would get 60 pi over 180, which would simplify to 1 pi over 3. Okay, same thing with the 125 degrees here. We would take 125, multiply it by pi over 180, and we would end up at 125 pi over 180, which would simplify to 25 pi over 36. Okay, when you're going and like simplifying in your calculator, just remember if you want to simplify 25 over 180, you can put that in your calculator and use your math button to simplify it, and then you just leave that pi there on the end. Okay, and then if we're going to go the other way, we are going to go from radians. Radians are in terms of pi, so these two questions here are both in radians because they are in terms of pi. Instead of multiplying by pi over 180, we're just going to go the other way. So we are going to take our radians and we are going to multiply them times 180 over pi. Again, that's essentially like multiplying times 1. And what that does, right, we're going to multiply it times 180 over pi. What that does is the pi's will always cancel, and then you can just multiply across in your numerator and your denominator. So we would end up at 180 times 3 divided by 4 would be 135 degrees. Okay, same thing over here. We are going to multiply it times 180 over pi. Our pi's are going to simplify out. Negative 5 times 180 divided by 6 is going to be negative 150 degrees. Okay, so notice one of these angles is positive, one of them is negative. On the next page, we're actually going to talk about positive and negative angles. So all angles are measured from a horizontal line, like the x-axis, right? So we're going to have a horizontal line, which is basically our x-axis for most of what we are going to do, okay? And counterclockwise angles are positive. So if my angle is going like this, right? So if I go like this and I draw my line, this is going to be a positive angle. So I'm looking at that and I'm like, oh, that looks like it's probably about, what, 50 degrees or so, something like that. If they go clockwise, on the other hand, meaning we go this way, and we have an angle here, this is going to be a negative angle. Okay, so up here, I would say this is approximately positive, like, let's say 70 degrees. Okay, this one would be about negative 30 degrees. I didn't actually measure those, I'm just estimating by looking. And then just a couple of other little things, just vocabulary type of stuff. Again, this is things that's a review preparing you for what you're actually going to have to do for college algebra. But just a reminder that a circle is always 360 degrees, and supplementary, also being like a linear pair, is another way we say that, always adds up to 180 degrees. Okay, so now getting started with what we're actually kind of going to start looking at is called the angle of inclination. And the angle of inclination is the positive angle. And as we start moving into higher level maths, we're going to get these Greek letters that we use for angles. And so this angle right here is called theta. Okay, so you're going to have a positive angle that's less than 180 degrees measured counterclockwise from the x-axis to the line. This angle should be between 0 and 80 degrees. Okay, so we are going to have, oops, oh, I didn't mean to do that. Let me erase that real quick. I meant to do so here's our, once again, I'm not going to erase that this time. Here's our horizontal line, okay? And our angle of inclination is going to be positive, right? So here, this is going to be my angle of inclination. Okay, and it always has to be positive, right? So this is positive, I don't know, let's say again, it looks like it's probably what, about 80 degrees or so. However, if we have a negative angle that goes like the other way, like we did before, that goes this way, okay, that's as an angle of inclination, though, we have to be a little bit careful on how we actually call it, how many degrees this would be. And what we can do is we can extend this line like this, right? So let's say this is negative 30 degrees. Again, I'm just estimating all those kind of things. Well, that's a negative angle that we can't have because it says right up here, has to be a positive angle. So what we do is instead we measure the one that is supplementary to it, which is this angle right here, okay? And in order to figure out what that blue angle is there that we have marked, all we would have to do is add 180 degrees. Okay, so this blue angle right here is going to be negative 30 plus 180, which is going to be 150 degrees. And now we have it as positive and a positive angle. Okay, so now what if we have to actually find the angle of inclination? We have to actually calculate how many degrees it is and things like that. So, I mean, we can't just guess every single time. And there is a formula for that, right? The formula is m equals the tangent of theta. This is making you dig back pretty deep into your Algebra 2 geometry trig stuff that we did for solving and things like that. But as far as the vocabulary, what you know, right? M is the slope, right, of the line. Because remember, we're doing an angle of inclination if we have a line. And then theta is actually the angle of inclination, okay? In order to solve problems like this, we're going to need to be able to solve and find theta. So this isn't actually using the formula. This is just straight up reviewing how to solve for theta if you are given an equation, right? So in order to find theta, when that's the missing piece, and remember the angle is always attached to the trig function, right, in this case. So we have tangent of theta. We're going to use the inverse, and we're going to express our answer in degrees, and then we're going to convert it into radians, and we are also going to give it as a decimal rounded 4 places. Okay, so once we have degrees, we'll just start kind of converting through. So just a reminder, again, this is just how to solve an equation when you have to find theta. So in order to undo theta, we do the inverse of it on both sides. Okay, and what that does is that gets rid of the tangent, and you are just left with theta. So you'd have the inverse tangent of 3/2. Okay, and you are going to have to become very familiar with your graphing calculator and things like that, which I think you guys already are pretty well. And so in order to calculate what, that should be theta, this is on our calculator, right kind of above the parentheses, 2 buttons above the 9, you're going to see the tangent button. And then if you hit the second tangent, it will put on your screen tangent inverse and then with parentheses on what you're going to put in there. So you're going to hit your second tangent and it'll give you a set of parentheses where you can put in that fraction. So you're going to put in 3/2. And hang on just a second. And you should get 56.3. Okay, so we're gonna put our answer in degrees as 56.3. So if you, on your calculator, when you followed those exact same steps and you got some decimal like 0.982, something like that, you need to check the mode of your calculator. So if you did not get 56.3 when you put that information in, you need to go to your mode on your calculator. That's right next to the blue button. And 3 or 4 rows down that says radian and degree, and make sure that degree is the one that's highlighted. If not, you're going to get, your answers are going to be all kinds of wonky, okay? So then once we have our degrees here, sorry, we are going to convert those degrees to radians. So we're going to have 56.3 times pi over 180. And in terms of, we're going to just leave it as 56.3 pi over 180. We're not going to actually simplify that. That's an ugly decimal to try to simplify. But if you'd use the pi button and actually calculate it out, 56.3 times the pi button divided by 180, you should get approximately 0.9823. So we'll be doing homework on this on worksheets where if you happen to be a 10th or a 100th, or not a 10th, but probably like a 100th or a 1,000th or something like that off, your rounding might have been different on where I actually rounded and things like that. But as long as you are within pretty darn close to that, you should be good. And those of you that did have it accidentally in radians to begin with and you got that 0.98 something on your calculator, that's actually what your answer is here, where you calculated it in radians, where your calculator automatically used radians instead of degrees, okay? So second one over here, let's do this one real quick here now that we've explained it. So we're going to take the inverse of both sides. Those are going to cancel. We're going to have left with theta equals the inverse tangent of 5/9. And when you put that into your calculator in degrees, it's 29.05 degrees. When you 0.05 pi over 180, when you actually calculate that out with your using the pi button, you should get approximately 0.5068 radians, okay? Okay, so now we are actually going to use that formula, and we're going to do a couple of problems where we're going to graph a line and we're going to figure out what the angle of inclination is from the x-axis to the line, okay? So what's the angle of inclination here? Your answer should be expressed in positive radians and degrees between 0 and 180 degrees, okay? So first thing we're going to do is graph this line. In order to graph it, we are going to need to solve for y. So I'm going to add x to both sides, and I get y equals x minus 2. When I graph that, I start at -2. My slope is 1/1, so I'm going like this. And some of you, just because you're super smart, might know that that's a 45-degree angle because it's coming out at a slope of 1/1. But what we are actually going to prove is that that's true. So we are going to find this angle of inclination right here, and that's going to be our theta. Okay, so in order to use our formula is m equals the tangent of theta. So that's our formula from the previous page. And we know our slope in this case, our slope is 1. So we are just going to do 1 equals the tangent of theta. And we are going to take the inverse of both sides. Again, that gets rid of my tangent. There you go. I'm going to take the inverse of both sides. And that's going to give me, if I put inverse tangent of 1, that's going to give me 45 degrees is my theta. And if I take 45 degrees and turn it into radians, I get 45 pi over 180, which is 1 pi over 4. Okay, so that one was a little easier just because you kind of had an idea of what the answer was before you actually started. The second one's going to be a little bit tougher. Okay, so let's take a look at that. All right, so now we have 2x plus 3y. Again, we're going to get this into slope-intercept form. So I'm going to subtract 2x from both sides. And I'm going to have 3y equals negative 2x plus 6. When I divide everything by 3, I get y equals negative 2/3 x plus 2. Okay, I'm going to use that formula of m equals the tangent of theta. Okay, and let's go ahead before I start solving anything. Let's see how big of an angle we actually have here that we're working with. So I have my y-intercept is at 2. Okay, so here's my y-intercept, and my slope is negative 2/3. So I'm going to go down 2 over 3, down 2 over 3, up 2, back 3, and I've got my line. Okay, so as you can see, as we're looking, our angle of inclination is this guy right here. Doesn't have to start at the origin. Okay, so here's our angle of inclination. It's going to be an obtuse angle. So this guy right here is going to be our theta. Okay, so he's gone past 90 degrees, so we're going to go ahead and have an obtuse angle. So we kind of have an idea of where we're going with this. And our slope, the m here, is going to be negative 2/3 equals the tangent of theta. And again, to get rid of that tangent, we're going to multiply both sides by the inverse. Okay, that gets rid of our tangents over here. So our angle of inclination, we're going to put in our calculator. We're going to do that second tangent. In the parentheses, we're going to make sure we put a negative 2 over 3. And our angle is going to be negative 33.69. Okay, well, the rule said it has to be positive. So what actually, by putting all these numbers in, what it told us was this guy here. It told us that this is negative 33.69. Okay. However, the angle has to be positive, so to find the positive angle, we should just add 180 degrees. Okay, so we are going to take negative 33.69 and we are going to add 180. So our angle, our positive angle of inclination is 140.3 roughly degrees. Okay, if we were going to change that into radians in terms of pi, we would have 140.3 pi over 180. And again, when we have decimals like this, we're just going to leave it as a decimal and pi in the fraction. We're not going to change it. If we wanted, if at any point it asks you for the decimal like we did on the previous page where we went 4 places and we rounded it way past that kind of a thing, we could, but we're just going to leave it like this. Okay, so our last example was the answer was a positive. This time it was a negative. Therefore, we had to add 180 to get our positive angle of inclination.